Today we're going to be talking about graphing sine and cosine functions with phase and amplitude changes. So we're going to determine the period and the amplitude before graphing, which is what we learned in the last lesson. The period tells us how often the pattern repeats, and the amplitude tells us how far from the midline the graph goes up and down. So key points to remember about the basics from when we did the spaghetti sine curve. The sine, the pattern is 0, 1, 0, -1, 0, or 0 up, 0 down, 0. And then cosine is 1, 0, -1, 0, 1, or up, 0, down, 0, up. Okay, so we're going to be graphing lots of functions here today. And this graph paper I did post on Google Classroom, so if you want to print some of this off to use for your notes, you're more than welcome to as well. So we're going to graph just the basic y equals sine of theta. Now you're going to notice here on the y-axis, we're counting by ones. Okay, so this will be 1, 2, 3, and then -1, -2, -3, and it would keep going from there. And then we are graphing in radians here. So we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so those are kind of your 5 important pieces to start off with. So with this, we do need to know our period and amplitude first. So remember, amplitude is going to be the absolute value of the number out front, and that is 1. And our period is going to be 2 pi divided by b, and b is the number in front of theta, so that's 1. So that means 2 pi, okay? So with this, that means we're only going to be going up to 1 and down to -1 throughout this process. And by the time we make it over to 2 pi, we're going to have our entire circle. Now, there is another thing that we can use called intervals, okay? So I guess I'll write it out. So intervals, you're going to take the period and divide by 4. This is going to tell you how often you're marking some important point on this. So for this one, we would take 2 pi divided by 4, which means every pi over 2, we are going to be marking something. So we start at, sine starts at 0. At pi over 2, we are up at the amplitude. At another pi over 2, which would be pi, we're back at 0. And after another pi over 2, we're down at -1. And then another pi over 2, we are at 2 pi. And this does continue on. Oops. Okay. So there would be our sine curve. And that looks a lot like what you did when you did your spaghetti sine curve. It's just a little bit more shrunken here because of the scale of things. Okay. But that would be your answer, that graph right there. So let's look at some other sine functions if we're changing the period and the amplitude. So again, we're always going to be graphing from 0 to 2 pi. So if you want, you can always just use this graph. If you, you can print them off, or you can just generally sketch something. All right, so we have f of x equals 2 sine of theta. So again, we need amplitude, we need period, and then intervals are going to be helpful. And you don't have to write intervals down, but amplitude and period, you should be telling me what they are. So here the amplitude is going to be 2, and the period is going to be 2 pi divided by 1, since that's a 1 there, or just 2 pi, which means our intervals, again, would be 2 pi divided by 4, which simplifies to be pi over 2. So every pi over 2, we're going to have something important marked. Sine starts at 0. At our interval, so pi over 2, we're going to be up at our amplitude. This time our amplitude is 2. At another pi over 2, we're back down to 0. Another pi over 2, we're down to the negative amplitude. And another pi over 2, we're back at 0. So it still has that same shape to it. And you notice it's got curve to it. It's not just a zigzag, okay? It's got curve to it. So if you're looking at these two graphs, so if we look here and here, this one's just stretched taller. Okay. So let's see what happens when we change where the 2 is. Okay. So we need amplitude, period, intervals. All right, so amplitude is going to just be 1. The period, we're going to take 2 pi and divide it by 2. So that means by the time we make it to pi, we should have 1 sine curve completed because there are 2 sine curves that happen by the time you make it to 2 pi. So then our interval would be pi over 4. So every pi over 4, we need to mark something. Now, we got to figure out where the heck pi over 4 is, though. There's 1, 2, 3 tick marks by the time we get to pi over 2. So that means that we're going to be marking every 1.5 spaces on this graph paper. Okay? So we start at 0 for sine. Our amplitude is 1. So at our next interval, we're up. Next interval, 0. Next interval, down. Next interval, 0. So you notice there I just completed 1 sine curve by the time I made it to pi, which is what we need to happen. So we're just going to keep going. Next interval up, 0, down, and to 0 again. So if we connect these, we have 1, 2 sine curves by the time we make it to 2 pi, which is what we need based on that 2 happening there. All right, let's look at one more sine function here. So we have f of x equals 3 times the sine of 4 theta. So our amplitude here is 3. Our period is 2 pi divided by 4, since our b value is 4. So that means that by the time we make it to pi over 2, we need to be done with 1 sine curve. And our intervals, we're going to take pi over 2 and divide it by 4, which means we take pi over 2 and multiply it by 1/4. So every pi over 8, we're going to be marking something. Okay, so we know that pi over 4 is every 1.5 spaces, so about every 3/4 of a space, we're going to be marking something. Okay, so there are going to be a lot of tick marks happening here. All right, so every one of those marks, we're going to be marking something here because of that pi over 8. So sine starts at 0. At our next tick mark, we're up to 3, and then we're back down to 0, down to -3, back to 0. So by the time we made it to pi over 2, we're done with 1 sine curve. And you keep following the pattern, 0 up, 0 down, 0. Now you want to make sure that you're not skipping any of your tick marks as you go. And by the time you make it to 2 pi, we should have 4 sine curves. So we have 1, 2, 3, and 4 sine curves. Okay, and so then it still has that same general curve to it. All right, so then let's see what happens if we have our cosine curve. So we have our parent function y equals the cosine of theta. And so again, we're going to find the amplitude and the period. So our amplitude is 1 and our period is 2 pi. So remember, for cosine, the pattern is up, 0, down, 0, and up. So it's still going to have curve to it, and it would still continue on in both directions, but you're going to start up first for things. All right, so let's take a look at just a couple of cosine curves here. So we have f of x equals cosine of 3 theta. So think to yourself, how many cosine curves should happen before we get to 2 pi? There should be 3 of them, okay? So our amplitude here is still 1. Our period is 2 pi over 3, which means our intervals are happening at 2 pi over 3 divided by 4. So that would be 2 pi over 3 times 1 over 4. So at every 2 pi over 12 or every pi over 6. All right, so where in the heck is pi over 6? With this, we have 1, 2, 3, 4, 5, 6 tick marks by the time we make it to pi. That means pi over 6 is every single one of these. So at every single one of these tick marks, we're going to have something marked there because they're all our intervals. So cosine starts at the amplitude, then goes to 0, down, 0, back up to amplitude. We keep going, and by the time we made it to 2 pi, we now have 3 cosine curves. So I should see the dots that you're making as you're going through and graphing. Okay, and again, these should have curve to them. It should not just be zigzags that you have going on. To make sure that you graphed one correctly as well, you can look at, all right, I'm at 2 pi over 3. 2 pi over 3 is the same thing as 4 6. So 1, 2, 3, 4 6 of pi we're there for. Okay, so let's take a look at one more here. We're going to graph f of x equals -2 cosine of 1/2 theta. So we need amplitude, which is going to be, all right, we need the absolute value of that. So that would be +2. Our period, we're going to come back and talk about what the negative does here soon. The period is going to be 2 pi divided by 1/2. So that means that we're taking 2 pi and multiplying it by 2 over 1. So the period of this is 4 pi. All right. So if we're getting only to 2 pi, that means we're only going to have half of a cosine curve that's going to happen. That means that our intervals, we're going to still take the period divided by 4. So we're only marking things every pi. You will not have a full cosine curve when you're graphing this. The negative out front, what does that do? Just like it did when we graphed our other parent functions, if there's a negative out front, it's going to flip it. Okay, so that means, and this goes for sines as well. So that means instead of starting at our positive amplitude of 2, we're actually going to start at our negative amplitude of -2. Again, that is because of the flip. So at our next interval, which is pi, we're going to be at 0. And then at the next interval of pi, so at 2 pi, we're going to be up at the positive amplitude. So this looks like it would just make a straight line. That's not what it's doing here. This is going to have some curve to it. Not much, since it's pretty stretched out, but there is a little bit of curve to it. And you got half of your cosine curve